Hello everyone, welcome to MLAS 700 Learning Activity 6, and this is kind of a labish, it's lecture lab, but we're going to be going over the lab equipment in this learning activity with a little bit of a treatment to Baremetal programming. I know I've talked about it a little bit up to this point, but we'll do a little bit more, and we're going to start off with the Arduino architecture. And we are using the Arduino Uno R4 Wi-Fi board. So this is one of the bigger boards. I think there may be only one board that's a little bit bigger than this one, the Arduino Mega. This one's actually up there in terms of its capabilities because this has connectivity for Wi-Fi. It also has a low energy Bluetooth capability with the ESP32 SC controller, and then S3 controller rather. And this uses a really neat chipset. It's got a 48 megahertz clock, 32K RAM, 256K flash on code, and then it's got a lot of different interfaces. It's got a CAN bus, a UART12C SPI. It's a 5-volt operating, can do 6 and 24 on the input range. The ESP32 actually runs off at 3 volts, so that's something you have to be careful with this one. But I don't know that we'll be doing any big shield / hat. And I'll talk through that. You're like, what's a shield? What's a hat? You know, those are things that are rider boards. They're carrier board. This is kind of like this is kind of like a small board computer. It's like an SBC, like a Raspberry Pi. It rises up to that level. It's like a SBC Lite, but it doesn't quite go to the level of a Raspberry Pi or a Jetson Nano. Those actually require Ubuntu or Debian, or they're Linux OS, and they take quite a bit more power to power. But those are true small single board computers, and they require they can do abstraction, and they're good for higher level programming interfaces. They're not good for bare metal programming. That's why we're using the Arduino architecture. But what's nice about the Uno R4 is it's got the almost the horsepower of a Raspberry Pi or a Jetson Nano. Not quite to that level. But it does have enough horsepower for us to specifically be able to do machine learning. And what I really love about this one is this has an ability to do edge computing IoT applications. So we can, because it has a Wi-Fi, the Bluetooth, we have a small form factor. It can be used in a control system. We can connect to it through Wi-Fi. We can connect to it with our phone. It gives us a lot more full, true cybernetic connectivity that we didn't have when we were talking about control systems that have humans in the loop in that regard. Okay, so let's talk about the Uno R4 a little bit more. So just a little bit of history on this thing. It's the latest version. There's a lot of different Arduinos. There's smaller ones. Excuse me. There's bigger ones, the Mega, but this one is probably one of the bigger ones you're going to come across. This one has a lot of capability. It has an onboard LED system that gives us a lot of neat things to be able to give us some instant feedback, which is nice. It has a nice pinout that allows us to put carrier, or I should say connected hats or hardware on top. And on top of the board itself, we can augment it. I don't think we're going to be getting any hats or shields for any of our projects. Most of everything that you're going to need is in the Elite Explorer kit. We won't be able to cover everything that you can do with it, of course, because of the number of parts. You have 1,000 different projects that you can use these things for. If tens of thousands of different projects. That's how cool this stuff is. But we'll definitely explore the big ones, right? I'll try to get us through. My hope is that I'm getting us through 2 labs a week with maybe a rider lecture that goes next to it. That's my plan, is a lecture and 2 labs. That'll get us through quite probably between, as we're moving along, you move along and get about 10 to 12 labs in, and as we get towards the tail end of that, we'll get into some of the machine learning capabilities. Okay, it's got a 32-bit processor. It's an ARM Cortex M4, and then a huge upgrade from the older 8-bit. And I said not 8-bit, but previous versions. You can do edge computing, and then we've of course got the Wi-Fi connectivity. And so some of the big features are, we've got a real-time clock on this. There's a memory protection unit. We have a DAC on it, so that gives us some additional capability that you wouldn't otherwise have. Memory, talked about a little bit about that. You've got a UART, an SPI, I2C, and a CAN bus, and then peripherals. There's a capacitive touching unit, CTSU on there. It has a full speed USB. And this is what's kind of cool. It's USB-C, so we've got USB-C connectivity, which makes life so much easier for us because we can connect on this board a USB-C for power instead of having to go through a barrel connector. Although it does have a barrel connector and we can power it. If we need to do something bigger, there is a barrel connector for powering that way. We don't need to do that because we do have the USB-C connectivity, which is nice, versus the micro, which is fine, but when we were using the Adafruit microcontroller in MLAS 650, that created its own problems, right? That's a much smaller microcontroller, and not as much capability, right? We had trouble being able to do some other stuff, but we could run high-level abstraction like small Python programs, and that was about as far as we could go. Now with this, we're going to be doing Baremetal programming, which opens up a lot of what we can do because they're a lot faster, a lot quicker, don't take up as much memory, and you got a lot of different things you can do from a C++ perspective. Okay. Power, mention the power, USB-C, and the barrel jack, and I think that's all. If you're interested in learning more, the data sheet is here. There's a link to it right there. There's a PDF. Feel free to go check that out. I highly encourage it. You can spend some time in there if you want to geek out on that a little bit more. I know I spent a little bit of time on it. It's kind of cool. You learn quite a bit. Next up is what can you expect? So we have what's called the Sun Founder edition of this. So it's a kit that took the Arduino Uno, wrapped it up into a kit, and then they packaged that up so it's got all kinds of resistors and capacitors, and it's got a breadboard, it's got a motor, it's got a temperature controller, it's got a pad, it's got a moisture sensor. It's got a keypad. I think I mentioned that already. I think it's got an ultrasonic sensor, and I think it has a display. Doesn't have I don't believe we have a TFT display on this kit, and we don't need that. Most of what we're going to be doing is going to be for it's going to be on the digital analog, the 8 excuse me, the 8-bit display. So actually, as I'm getting my voice back here a little bit, it does have a TFT with it. So that's actually encouraging. We've got a servo. There's other things that we have on here as well, and I think it's a stepper motor that's part of this, which is kind of neat. But yeah, it does have it has a regular display as well as a TFT display, so that's perfect. So that'll be nice for us from an edge IoT perspective, because we're going to be able to do a lot of cool. My big thing is we'll work up through some of the basics, then we'll get to some edge projects and machine learning projects, and then maybe a mix of at the end edge and machine learning projects. So it's going to be really, really neat. I'm pretty excited about this one. If you couldn't tell, this is a pretty cool microcontroller, and we kind of, from MLAS 650, we kind of had to do the basics of autonomous systems, before we could get you into this part, which is this course is a little bit more advanced because, of course, it's the bare metal programming, and then we actually are getting into more of the machine learning. So we're diving into a deeper treatment of it. So we will be doing quite a few things in this. This will be fun. Okay. Next up is we're. I just want to talk a little bit about the Arduino programming language. So it's what I really appreciate about the Arduino is you don't have to be a full-on CS major. You don't have to be a full-on programmer. You don't have to be a software engineer to do Arduino programming. They use what's called simplified C. It's simplified C++. It's a great bare metal programming for us because it has a simplified syntax. It's based on C. It's C++. C++ constructs. And so we can go as far as running C, and we can get that low if we want to. But we don't. Some of the more complicated stuff are abstracted off. We don't have to worry about it. So it makes it easier for us. We don't have to have a lot of deep knowledge to do programming on the microcontroller. So when you look at it, we're going to actually be using what's called Sketch, or we create sketches, and we're going to be using the Arduino IDE, which is what you see off to the right. And we'll be programming primarily in that interface and working through that, and then going and exploring both the cybernetic part of it, which is, of course, the human in the loop pieces of it, and then control systems and control theory, and then we'll talk through what that looks like from a machine learning perspective and how we integrate that into the hardware. And it's going to be very experiential. We're going to be doing a lot of lab work in this, and so I hope you find that to be useful for this course. Okay, I believe I think that's it. So that is our last lecture, lab stylish kind of. We're not doing any lab, but anyway, last lecture of the week. What I do want you to do, here's kind of your lab work on your own, is unpack your Arduino. Get familiar with it. There's a lot of anti-static packaging, and you'll have to spend some time pulling it apart. And what I want you to do is install the Arduino IDE. I'm actually going to switch over here real quick. And all you need to do is pull up a browser and Arduino IDE, and then come over here and then get a download going for whichever one you're on. What's nice about this is this works on Mac OS. It also works on Linux, which is a Mac, but yeah, it works on Mac, but it also works on Windows as well. I will be primarily working off of Windows. This will work for you under Mac, but just know that when I go through and start to pull this all down, and we're going to go through the Arduino development in the it's going to be on a Windows side, and we'll be working off of that. Okay, so so I want you to go out there, download your version of the one that you're going to be doing. I'll make that part of my lab for next week. We'll do another machine learning lecture, and then that'll kick the week off next week. And then I'm going to go ahead and do 2 labs. One of them will include downloading the Arduino, getting it set up, getting the environment set up, and then getting into like doing a test case, getting the Arduino connected, and then getting an LED to blink and do some basic programming. So it'll be fun. We'll have a good time with it. But yeah, this'll if you don't go through the process of downloading it, what I was going to say is no worries. I'll take care of that too on my end through a lab, so you can see how it works. But I do want you to pull your box out and get the Arduino IDE going, and then I will have as part of this week's when I unfurl the weekly modules. I do want you this week, and I want you to create a learning reflection paper. And then that'll be your first assignment. So I'll get that uploaded, and you'll see the due date on that, and then you should be good to go past that. Okay, that's all I've got. If you've got any questions, of course, feel free to hit me up in text or email, and I will see you next week.